Welcome to lesson 4.6. We are done with triangle proofs. We're moving on to isosceles triangles. Now, just to do a quick review, remember there's three different types of triangles. There's scalene, isosceles, and equilateral. The scalene has no congruent sides and no congruent angles. Sorry, Mr. Scalene, you're not looking so hot. You know, these sides are definitely not congruent. They're all a little different. Isosceles has two congruent sides and two congruent angles. Alright, so I'd have two sides that are congruent and two angles that are congruent. And the way I like to look at this word is I see the word isolate, right? So always imagine there's like this one angle who wants to hang out with the other two angles, but he's not congruent, so he can't. So he's like always stuck all alone and he's isolated. It's just what I used to remember it. It might say something about my childhood, but let's not even talk about that. And finally there's equilateral, which has three congruent sides and three congruent angles. Alright, three congruent sides and three congruent angles. And we're going to talk more about equilaterals in the next lesson, but we're going to focus on isosceles triangles this time. So first, what is the isosceles triangle theorem? What is the property of isosceles we need to know? And it's this. Congruent angles are opposite congruent sides. Okay, so C and B are my congruent angles. This is an isosceles, so it has two congruent angles. And they are opposite the congruent sides. Right? It's not going to be two random sides that are congruent. It's the ones opposite these angles. So to show you what I mean, all right, I'm just going to draw a line across. So across from C, opposite C is this side, AB. And opposite B is this side. So I know that these two sides must be congruent because they're opposite the congruent angles. So if C is congruent to B, then we know that AC, in this example, must be congruent to AB. And that's because congruent angles are opposite congruent sides. Now just to show you a counterexample to this, just to quickly erase this guy, it's like this. These two angles are congruent, right? I can't just pick any two random sides to be congruent. I can't say, oh, well, this and this are congruent. That's just not true, right? It has to be the sides that are opposite the congruent angles, okay? So it has to be these, this and this. And if you look at it, it even looks the same. Moving down. The opposite is also true for the isosceles triangle theorem, okay? So if I know I have two congruent sides, the opposite angles must be congruent, right? So I just can't randomly mark like, oh, this must be congruent to this. No, don't do that. You need to draw your line. So I start at DE, side DE, and opposite side DE is angle F. And opposite side DF is angle E. So since these sides are opposite these angles, I know F must be congruent to E. So if ED is congruent to DF, we know angle E is congruent to angle F because congruent sides are opposite congruent angles. Okay? And that's really the main takeaway. If you could draw these lines and say which sides are opposite which angles and which ones must be congruent, you've got this lesson down. Everything else is easy from there. So just make sure you're understanding these two concepts. So let's put this into practice and see what that looks like. Okay? Let's move out a little. Okay. So we're going to find the missing angles in triangle DEF. Okay? Let's find all the missing angles. And the way to do it is this. Well, I'm looking at this and I see it's an isosceles triangle, right? Because I have these two sides that are congruent. So I know that the opposite angles will also be congruent. So I'm going to draw my line. So I draw my line here, okay? And I draw my line here, right? So these two arrows are pointing to the congruent angle. So that tells me that this angle must be congruent to this angle. So if E is congruent to F, I know that F is also going to be 65 degrees, all right, because these two are congruent. That's why I drew my lines. Now to find angle D, we're going to go to the fact that triangles all have 180 degrees in them. So I'm just going to do 180 minus 65 minus 65. That's my two angles, and that gives me 50 degrees. So angle D is 50 degrees. Sweet. All right, in the figure below, we know that CA is congruent to AT, all right? And we should probably mark that. CA is congruent to AT, all right? Those are sides. We want to find the missing angles. Well, first let's start by drawing our lines again, okay? So we know that opposite the congruent sides are congruent angles. So I'm going to draw my line so I know this angle and this angle are congruent. And now I'm going to make my congruent mark. So C and T are congruent. Now, I don't know either of these angles, right? So I don't know what they are, but I can do this. When you don't know an angle, let's just put an X there. So I don't know what this angle is, right? Let's put X here. Since I know these are congruent, I know this also must be X. Well, now I could set up an equation because I have my three angles, right? So it's X plus 80, the three angles, equals 180 degrees. All right? To solve it, I just subtract 80 from both sides. All right? I get X plus X equals 100. I combine these, I get 2X equals 100. And finally, I divide by 2. And I get X is equal to 50 degrees. So I know angle C is 50 degrees. All right, and I know angle T is 50 degrees. And let's check to see if that even makes sense. Well, 50 plus 80. Well, let's see, 50 plus 50 plus 80, that's 180 degrees. So yeah, that does make sense. And these two are congruent, and we did it. Moving on, find the length of side AB. Okay, that's this side right here. Okay? Now let's see. I know this in isosceles because I have two congruent angles, right? So this must be an isosceles triangle. There's two congruent angles. Now, one side length is 12 and the other one is 15. Okay? And I have to figure out which, if this is an isosceles, two of the sides are going to be the same, but which one is it, 12 or 15? Well, let's just draw our arrows to see which one it is. So we're going to go opposite 40. Okay? We know this side and opposite this other 40. And this side must be congruent. So we mark them congruent. AB is congruent to BC. And since these two are congruent, we know this must also be 12. Great. Okay. And let me just write that out. AB is equal to 12. Okay. Final question. In triangle DEF, the measure of angle D is congruent to the measure of angle E. All right? Well, they didn't label this for us, so let's write it out ourselves. We got D, E, and F. Okay? Find the length of side DF, okay, if DE is equal to 9, all right, and FE is equal to 12. All right, DE is here, that's 9, FE is 12, and also we know D is congruent to E. So once again, we know this in isosceles because two angles are the same. And we want to find the missing side, which has to be one of these two, because in an isosceles, two of the sides must also be the same. To figure out which side it's congruent to, let's draw our lines. So we're going to draw a line over here, all right, opposite E and opposite D. So we know EF and DF are congruent. And make sure you're drawing these congruent lines so you know which ones are congruent. So since EF and DF are congruent, DF is equal to 12, and we can just say DF. Sweet. So once again, I just want to emphasize this. If you could draw your lines and state which sides and angles are congruent, you're doing fantastic. All right, let's throw a little algebra into the mix and see if we can use these isosceles properties to solve these. Well, in triangle FGH, the measure of angle F is congruent to the measure of angle H. Side GF is equal to 10, side GH is equal to 2x, and side HF is equal to 14. What is the value of x? Well, if no one's drawn that triangle for you, guess whose responsibility it is? It's your responsibility. So draw yourself a nice looking isosceles triangle. Luckily, I got my computer, so I got a nice one looking over here. Now let's label it. This is F, G, and H. All right. What this tells us is that the measure of angle F is congruent to the measure of angle H. So these two angles are congruent. Furthermore, it tells us that GF is equal to 10, GH is equal to 2x, and HF is equal to 14. Now, I'm first going to start off by telling you what not to do here. And this has been pissing me off major because I've been seeing kids doing this and it just hurts my heart every time I see it. Do not do this. Oh, look, I have three numbers. So, and this is a triangle, so that must add up to 180. I bet that's even what you thought right now. So I'm just going to add 10 plus 14 plus 2x equals 180 and solve for x. Boom, hell to the no. Do not do that. You cannot set these sides up equal to 80 because the sides of a triangle don't always add up to 180. Only the angles add up to 180. So if you're talking about sides, do not just say like, oh, there's three numbers, I got to put it to 180. No, that's degrees, and degrees are used to measure angles. Sides are completely different. The way you do this is quite straightforward. What you're going to do is draw those arrows. You're going to see which sides are congruent to each other. So opposite F and H, we have these two sides. We're going to mark them congruent. Okay? And here's what you do. You're basically asking yourself, for what value of x would make 2x equal to 10, right? Because these two sides have to be congruent. So you could just say that 10 must be equal to 2x. Just to tell you for the future, if you know two things are congruent, for example, if I know GF is congruent to GH, you can always set up your equation by just setting them equal to each other. So 10 is equal to 2x and solving from there. So divide by 2, and I get x equals 5. And that makes sense, right? Because 2 times 5 equals 10. And now these two sides are congruent. You might be asking me, well, why is that 14 there? I don't know. It's there to confuse you. Part of being good at math is being able to distinguish what information is important and what information isn't important. That's half the game. All right, in triangle ABC, AB is congruent to AC. Well, there's no triangle drawn for us. I know you saw the triangle there from earlier. Anyway, you have to draw your own triangle. So let's draw our own, okay? So we got our triangle here. All right? So let's label it A, B, and C. And we know that AB is congruent to AC. The measure of angle A is 5x plus 10. That's this angle over here. And the measure of angle B is 3x plus 26. All right, let's just fill that in. Find the value of x. And once again, I think we have this kind of gut reaction. We're probably going to have to set these equal to each other, but not so fast, right? Let's find out which angles are congruent. So we're going to draw our lines. All right, so we know this angle and this angle must be congruent. So I can't say that these are congruent because they're not. A isn't congruent to B. B is congruent to C. But what I can do is say this. Since these two are congruent, C must also be equal to 3x plus 26. If they're congruent, that means they must be exactly the same. So let's set them equal. Well, now, this reminds us of lesson 4.1. We have three angles, right? And we know they all add up to 180. So all we have to do is set them equal to 180. So 5x plus 10 plus 3x plus 26 plus 3x plus 26, and we get equals to 180. All right. Now that we've set up our equation, we can solve it. So let's go ahead and do that. We'll subtract 10. All right. We'll subtract 26. All right, we're just moving all the numbers to the other side, and we're going to subtract 26. Just moving all the numbers to the other side. All right. When we do that, cancels, cancels, and cancels. And we get 5x plus 3x plus 3x is equal to, let's see, 180 minus 52, 62 is 118. From there, we combine our like terms. We know that all of these are on the same side, right? So when they're on the same side, we just combine them. So we get 11x is equal to 118. We divide both sides by 11. And we get x is equal to, well, let's see, 118 divided by 11. I can't even do that in my head. So I'm just going to check that out on my old trusty calculator. 118 divided by 11 and that's 10.72, and I'll round it up, 727, so it's 10.73. All right, moving along, final problem. In figure below, BD is congruent to BC. All right, BD is congruent to BC. Find the measure of angle A. All right, let me walk you through this. Once again, we know that we have an isosceles triangle right here, so we could draw our lines, okay? Let's start by doing that. Let's draw our lines. We know that these two angles must be congruent. This angle will be congruent to this angle. So we could say that this is equal to 48. Sweet. From there, I'm just going to get that out of the way now. It served its purpose. We could solve for this angle, right? Because 48 plus 48 is 96, all right? And this is a triangle, so we do 180 minus 96. That equals to 84 degrees. All right, we got this triangle figured out. Let's keep figuring out. Well, once again, we know that this is a straight line, right? And in every straight line is 180 degrees. These two angles will be supplementary. So to find out what this angle is, all I have to do is 180 minus 48, right? Because that's a straight line. Take away the 48, that will tell me what this angle is. When I do that, I get 132 degrees. All right, we're cruising now. How am I going to find my final angle in this triangle? Well, if we look over here, this is once again another full triangle. So to find out our missing angle, all we have to do is 180 minus 132 minus 26, and that should equal, oh, I know I'm going to get this wrong, and then you guys are going to tell me about it in class, but I'm going to give it a shot. 22? Is that right? I hope so. 22 degrees. Okay, so angle A is equal to 22, and that is it for this lesson. So just remember, whenever you see an isosceles triangle, all you have to know is that the opposite sides are, the congruent sides are opposite the congruent angles, and the congruent angles are opposite the congruent sides. Draw your arrows, see what's congruent in the triangle, and you're good to go. All right, guys, remember, don't ever spit on a baby. They get sick very easily.